Hello everyone, welcome back. Before we start our class today, if you guys can please get logged into the Kahoot. While we're waiting for everyone, I'll post the link in the chat. That'd be much appreciated. Very much appreciated. So, the Kahoot is in the chat. If you can sign in um while we wait for everyone else to come in. So if you can't see it, the game PIN is on the screen. Um, and we'll start in about a minute, all right? Um, so just as a review, last class we learned about prime factors. And can anyone in the chat, or if you can unmic, that'd be awesome too. Can anyone tell me what prime factors are of a number? Henry? Oh, Ryan, go ahead.
You mean prime numbers?
Mm-hmm.
Prime number are numbers that have exactly two factors, which is the
Exactly.
number itself and one.
Right. So prime factors are divisible by only two unique factors, right? We learned last time that one is not prime, and it's not composite either. But any other prime number is divisible only by one and by itself, right? That those two have to be different. So, do I have any other volunteers who'd like to tell me what a composite number is? Jason, can you tell me what a composite number is? And thanks to Ryan Lin for turning on his camera. If the rest of you have cameras, you guys can turn it on too. You don't need to like show your face. You can just turn on an avatar or anything. That works as well. All right. So thank you, Garrus. I see you've had your camera on. Do I have any volunteers who want to tell me what a composite number is? Jason or Ziran? Okay, thank you, Ryan. Ziran, can you tell me what a composite number is? Or you can just type it in the chat. In the meantime, uh, we also learned about how we can tell certain numbers are divisible by smaller numbers. For example, let's go over some of the more basic ones. For example, if I had some really large number, I'm gonna type it in the chat. How can you tell me if it's divisible by two? Okay, let's say I type in 4, 5, 6, 9, uh, or something like this. Can you tell me whether this is divisible by two or not? Okay, Ryan says yes. Nancy says yes. Okay, so why is it divisible by two? Can we have a quick refresher on why? Ryan, you can unmute yourself if you like. In the meantime, can you guys also tell me if that number is divisible by three or not? Okay, Zran, what question were you answering? So I was asking whether I think the question I asked you was what is a composite number? And yes, Ryan, um, that big number I typed in 45,698 does have an even number at the end. Um, so what was the other trick I taught? Um, for example, let's take that number again. I think it was 45,698. Can you guys tell me if that is divisible by three or not? So it's actually a very simple trick. You don't need to do all the division. Nancy says no. I think most everyone in the chat is saying no. Why isn't it divisible by three? You guys can unmute yourself. That way we can speak. We can do the review a bit faster and get on with the lesson. Yes, Brian is correct. If you add all the digits, you have to sum the digits, and then when you do the division again, you'll find out it's not divisible by 3. I'm pretty sure if you add all of this up, you're going to get a remainder of I think it was like a remainder of 2, because 8 divided by 3 is divided by 3, you get a remainder of 2. So it just doesn't work out. Um, One thing I actually forgot to mention last class is that using the division by 2 rules and the division by 3 rules, you can continue pushing on. So not only can you find out whether a number is divisible by 2 or divisible by 3, you can check again to see if a number, for example, is divisible by 4 or divisible by 6, numbers like that. So I'll teach that later in the class, but just to get everyone warmed up, I'm going to go down the list and ask you guys to do more multiplication problems. They're going to be quite a bit harder, but let's make this fast. Everyone, I'd like everyone to unmute themselves. Ethan, can you please ask everyone to unmute? I'm just going to go down the list, and we should be shooting this off like machine. All right, thank you, Garrus. I'll be asking you first. Can you tell me what 5 times 4 is?
I think that's 20.
Correct. 5 times 4 is 20. Ryan, what is 6 times 7?
420.
6 times 7.
Wait, could you say the question again?
I'm asking what is 6 times 7?
Oh, 42. I thought you said
42.
60 times
Yeah,
7.
not 60. Just units digits for now. Scene, can you tell me what 8 times 5 is?
It's Sean.
Oh, Sean. Okay. Sean, can you tell me what 8 times 5 is? I'll take notes on that.
40.
40. Thank you. Jason, can you tell me what 9 times 8 is? Remember,
72.
pardon? 9 times
72.
Yes, it is 72. Kevin, you can type in the chat if you want. I'm gonna bring in some double digits now. What is 11 times 12? I'm not sure if you've learned your multiplication tables up there, but you can try doing it really quick on paper and pencil. What's 11 times 12? Okay, if Kevin's still, thank you, 132. Lawrence, if you can unmute yourself, please do so. What is 10 times 21?
210.
210. Thank you, Lawrence. William, can you tell me what 12 times 9 is? That's actually, I think, a pretty hard one. 100 and
120.
I'm asking 12 times 9, not 12 times 10. So you're close. You can work.
84. 98.
So 120 is 12 times 10, right? And then I'm asking you what 12 times 9 is. Would anyone like to help William out in the chat?
12 times 9 equals 110.
Uh,
108.
108. It is 108 because you take 120, you can subtract 12 to get 108. Because multiplication is really, really speedy addition, right? That was a pretty hard question, actually. Can someone tell me, let's see, who's next in the list? Uh, is it Giranzo? Can you tell me what 13 times 11 is? I'd like this to be really fast, all right? If you guys can all unmute yourself, that way we can speed through this quicker. So what's 13 times 11? Okay, would anyone like to help Jiran? Okay, 13 times 11 is 143. Thank you to everyone who's typing in the chat. Let's bring it even harder. What is 12 times 14? I'll ask that to um, Ryan. What's 12 times 14?
12 times 14.
Mm-hmm.
You can calculate 168.
168. Okay, I believe that is the correct answer. Okay, next, I'm pretty sure everyone's more or less warmed up, right? I mean, I'm not just asking like one person to do it. If you guys, you might not be turning on your mics, but you should be doing some of these questions in your heads too. So one of the reasons I'm asking you guys to do even more multiplication problems, and some of them are harder this time, is because I'm going to be introducing something called powers and exponents. So, powers and exponents, has anyone learned about this yet? You guys can raise your hand if you have, so we don't blow up the chat too fast. Yeah, thank you, Ryan. Okay, thank you, Kevin. I suppose lots of people have, at least two people have, learned powers and exponents. Would you guys like to provide an explanation to anyone else who hasn't learned what you think powers and exponents are? Ryan, I'll let you take a seat. Take the mic.
Could you say what you say again?
So can you explain to everyone else what powers and exponents are?
So, exponent is a number that times itself. Like example, 7 to the power of 2. You just need to times 2 7. Like the tiny number on the top is the exponent. The large number is the base root. So you just need to know. The main thing is you need to know how much. What's the the exponents example is 3, so you just need to multiply a number by 3 times itself, like triple.
Right.
Like,
So I think you got most of the concepts covered. For example, I heard you mention concepts such as base and exponent. Those are very important things to know when you're talking about exponents. So if do I have any volunteers who would like to read the highlighted text down here? I put at the bottom. Well, there isn't the text here. Any volunteers other than Ryan? I appreciate your participation, Ryan. Lawrence, would you like to read this, starting with repeated multiplication?
Repeated multiplication of identical factors can be written using exponent and a base. The base is a number used as a factor. The exponent indicates how many times the base is used as a factor.
Okay, thank you. So as we see in this example, 32 can be broken down into its prime components, right? We see that 32 can be broken into 2 times 2 times 2 times 2 times 2. So exponents and exponentiation, that's what the overall concept is called. It's fast multiplication. So you know how it's pretty much the same analogy where, let's say if I wanted to count something, right? Let's say 1, 2, 3, 4, 5, 6, 7, 8. That can take a long time. So if we want to do really fast counting, we can use addition, right? I can just go 1 plus 9 is 10. Boom, that's 10. But sometimes if you add lots of things, that can take a long time too. So if you want to add really fast, you use multiplication, especially if the numbers, they're all the same. But sometimes you want to go up even faster. And in this case, you would use exponents, right? So you would multiply, for example, in this case, 2 to the power of 5. You see there are 5 2's multiplied by each other. You have 2 times 2 times 2
It's
times 2
6:15.
times 2. So you do all that multiplication, and in the end, you get 32. And below here, we also have something, it's just commonly understood that when no exponent is given, right? If I just, for example, if I annotate on the screen, if I write, for example, 2, oops, if I write 2, if I just put a 2, we understand this to be 2 to the first power, which means it's just 2 is just 2, right? It's the same concept as I don't know, 199 is the same as 199 to the first power. It's pretty much the same concept. And well, there are some pretty common ways to express exponents. If we look over here at this box, we'll see that some of the more common ones are, for example, squared, if it's just two things being multiplied together, and if it's three things being multiplied together, we say it's something cubed.
Cube. I mean, not cubes. Yeah, just cube.
So Ryan, do you know where these words come from? Why do I say 3 times 3 is 3 squared? Or 10 times 10 times 10, why do I call that 10 cubed?
Because like if you say like 3 times 3, you can actually make a square with it. You can make a
Right.
square, so you just call it squared. And 10
So-
times 10 times 10, you can make a cube with it, like
Mhm.
the height times length times the
width
width.
is the volume of the shape you get, right? So if we're just going with this example right here. If I draw a 3, this is just a line. Let's say this is 3 units long. And then I draw another line. This is also 3 units long. Would you guys know how to calculate the area of this thing? So like how much
9. 3
cover?
times 3.
Exactly. So the area, because this is a square, presumably, I know it's actually a pretty decent square. So it's just 3 times 3. 3 times 3 would equal 9. And because the area of the square is 9, you simply say 3 squared is equal to 9, right? You can use this with any other number. It can be 4, 5, 6. It can be a decimal. Even with negative numbers. I mean, I haven't seen a negative square before, but if you have, I guess if you can take a picture, show me. Not that you'll probably ever find it, but the same thing applies with cubes. I'm gonna try and project a 3D image on here. If I take a cube and then I gave each dimension is a 10. This is a 10. The height is a 10, and then the width is also a 10. Then the volume would be 10 times 10 times 10, which in the end we will get 10 cubed, right? So let's look at this one of these examples. If you have this long statement, 3 times 3 times 3 times 3, how are we going to write this as an exponent? Do I have any volunteers? Okay, Ryan?
3 to the power of 4.
3 to the power of 4. Okay. So if let's say pretend we've never done this before. What are the two parts we need to write if we want to write an exponent? Let's just take this one by one. Okay. So we know in an exponent there are two things, right? So first is a base, and can someone in the chat tell me what the base of this big number is? Kevin, can you tell me what the base of this? Oops. Yeah, I think I skipped a bit too much. Kevin, can you tell me what the base of 3 times 3 times 3 times 3 would be? Kevin, are you here? So the base, it's the number that's being multiplied, right? So in this case, it would be a 3. So 3, and we see that 3 appears 4 times. You have 1 3 here, you have 1 3 here, you have another 3 here, and you have the fourth 3 over here, right? So there are 4 3s. So in this case, you can express it as 3 to the 4th power, right? And in terms of power, we just say it's like powerful, because exponents, they are really powerful. You can make numbers go really, really, really fast with powers. So going off the page, let's say I have another expression. I'd like to tell, do I have any volunteers who can tell me what 7 times 7 times 7 times 7 times 7 would be equal to? How would I compress this? Or how would I write it in exponent form? Can someone tell me the base and someone tell me the exponent? So the base is the big number. Or it's the number being multiplied. Anyone in the chat? Someone other than Ryan, please. I know you've been participating a lot, Ryan. Garrus, can you tell me what would the base be in this case?
7.
7. Why would it be 7?
Because it's basically like 7 plus times 7 times 7 times 7.
Well,
Basically, mostly
why isn't it 5? Why don't I put something like 5 to the 7th power? What's wrong about this? Is this correct?
Nope.
No, well, why is it wrong? I mean, there's 7 and then there's a 5. It works. 5 sevens.
They're both in the wrong place.
Oh, they're both in the wrong place. Okay. So where should I put them?
You should put the 7 at the long one,
At the bottom, right? It's the big number.
and then the 5 at the top.
Okay, so why is it a 5? Why don't I put any other number? Can you tell me why it's a 5?
Because it's like 5 sevens.
Right, it's being
It's
multiplied
like
by
7
itself 5
times
times.
7 times 7 times 7 times 7
Exactly.
repeated.
Exactly. I think you're getting it. Do I have any other volunteers? I'll write another really long multiplication sentence. Someone in the chat give me a random number, please. I'll just fill out this.
12.
12? Okay, thank you. So, okay. Those numbers are actually pretty big. So, well, I'll just use 12 over here. So let's say I have 12 times 12 times 12. I'll just keep it at that. How would I simplify this? Any volunteers? Jocelyn? I see you're participating. So how would I express this? What would be the base and what would be the exponent?
12 is the base.
Thank you. And what is the exponent?
3.
3. Thank you, Zirang. I see you're participating again. So can you explain why 12 to the third power is correct and not, for example, 3 to the 12? Why is this not correct? So how come this, why can't I write it like this? Jocelyn? Are you here, Jocelyn? Okay, do I have any volunteers who'd like to tell me why 3 to the 12 is incorrect, but 12 to the third would be the correct notation? Because I know if you're just getting started with exponents, this is very easy to confuse up with. If you see something like 3 to the fourth and 4 to the third, both in like the same expression, you can easily get confused. You might end up writing, you might just end up confusing them. Okay, I'll let Ryan take the floor again.
Because you know the base number is the number that's the original number, which is 12 times 12 times 12. 12 is the original number, which is the base number. So 12 is the big number, which is the base.
Mhm.
And it's the little numbers, like it means how much 12 are there. And there's
Yes.
3 12, so you just write 3.
It is only being multiplied 3 times. If I wrote 3 to the 12 back in standard notation, that would take me like at least 5 minutes to write it all out. But I think it'll be something like 3 times 3 times 3 times 3 times 3 times 3. You get the idea. There will be 12 threes all being multiplied together, and that's a pretty big number, really. I think it's even bigger than 12 to the third. But I'm pretty sure everyone is more or less getting how we can write exponents, how we can break them down and split them out again. But in this textbook, what they don't introduce is some rules we usually use with exponents. Okay. Okay. So Ethan says that Jason says because 12 to the third will only be around 1000, but 3 to the 12 will be way more. Yes, that is correct. Because once you expand 3 to the 12, you get like 9 multiplied by itself 6 times, and then you get 81 multiplied by itself 3 times. And because 81 is greater than 12, it's a ridiculously big number. So here I'm going to introduce something. Let's say I have 2 cubed, all right? And I want to multiply this by 2 to the fourth. Okay? Have you guys ever seen how we can simplify this really quick? I know you guys can simply go like, yes, Ryan.
So the base number is still the same, but you just add the exponents up. 3 to
Exactly.
7.
So in this case, we can just write it as 2 to the power of 3 plus 4. So why does this work? How come, why is it 3 plus 4, not 3 times 4 or some other gibberish thing? Can you tell me why this works, Ryan?
No, I don't know.
You don't know? Well, it actually lies in how we break these numbers down, right? So how would you expand 2 to the my tongue's getting tight. How would you express 2 to the third or 2 cubed? So we see that 2 to the third. I'm just gonna box this up. 2 to the third is 2 times 2 times 2, right? This is 2 to the third. We
Huh?
can simplify it as 8, but I'm not gonna do that right now.
Oh, I know now because
Oh,
if you just make them to the this form, you just need to you just like gonna add it up.
mhm. Right. So
Because
once you expand them, you see that you have 7 2s. 2 to the third, we know it's just 2 times 2 times 2. You guys see that, right? It's boxed up on the left.
yeah,
2 to the fourth, I'm just gonna enclose this with a box, so we see that 2 to the third is a box, and 2 to the fourth is a circle. They look ugly, but I think you get my point. And we see here that 2 cubed is 2 times 2 times 2. That's 3 2s. And 2 to the fourth is 2 times 2 times 2 times 2. That's 4 2s. And then when we multiply them together, we get 7 2s all multiplied in a row. So we see that 2 cubed times 2 to the fourth is the same as 2 to the seventh, right? And we didn't really need to break this down. I mean, if you wanted to, you can break it down. But once, I know in math contests, you get ridiculously big numbers like, I don't know, 2023. You're not going to write out 2023 twos in a row. It's just a waste of time, really. So we can simplify this as just 2 to the 3 plus fourth power, where you just get 2 to the seventh, right? Do you guys see how that works? So that's just a useful little trick you might see sometimes. Here's another one. Let's say I have, instead of 2 to the third times 2 to the fourth, let's say I have 2 to the fourth divided by 2 to the third. How would I simplify this, Ryan? Go ahead.
you just minus the exponent.
Okay, so I get 2 to the 4 minus 3. And what would I get?
2 to the power of 1, which is only 2.
2 to the power of 1, which is the same thing as 2, right? So do you see how this one would work if I copy the same logic I used for the addition property?
Yeah,
How would it work? So let's say we break down 2 to the fourth into its parts. What would I get?
2 times 2 times 2 times 2.
All divided by,
And then 2 times 2 times 2.
right, 3 2s in a row. And we see that 3 2s in the top cancels with 3 2s in the bottom, right? They just go poof, poof.
And
And,
the 2. And
and then
then
all you get left is a 2. You see that? So if
yeah.
these numbers get ridiculously big, let's say instead of a 4, I have like a 400, and instead of a 3, I have a 399, you are not going to compute 2 to the 400th power. No way are you doing that. Your calculator can't do that. I mean, a supercomputer probably couldn't do that. I mean, if you added enough zeros at the back, and 2 to the 399 is equally as complex. But if you know this property, you don't need to calculate whatever 2 to the 400th power is. You just do the subtraction. 400 minus 399, that's just 1, right? So
Yeah.
in this case, you can simplify this really, really quickly. You don't
It's
go like,
6:30.
oh no, 2 times 2 times 2 times 2. You just simplify it like magic. That's that's pretty much what it is. So that was the addition property of exponents, and then this was the subtraction property of exponents. I'm gonna clear the screen. Let's do one more. Let's say I have I'm using a lot of 2s today. 2 to the 2 to the third, and then I square it. Wow. 2 to the third squared. How would I simplify this? What's another way I can write this? Ryan, I appreciate your participation, but once again, I'm gonna ask somebody else. Do I have any other volunteers who know how I can simplify this? For example, if I take 2 to the third squared, how would I write this so that it's just a base and an exponent? Sean? Do you know what I can do here?
So you do the middle one first.
Okay. What do you mean by I do the middle one first?
So you do 2 times 2 times 2.
Okay, and what is that? What's 2 times 2
And,
times 2?
and then you
Okay, so I have 2 times 2 times 2. And then when I square it, it's the same thing as taking this big mumbo jumbo, and I take it and I multiply it again. You see that?
yeah.
Yeah. And now in this statement, how many 2's do you see here? In
2, 3,
okay, so there's 3 in this box. And what about in this box? In this circle,
3.
there's 3. So there's 3 here, there's 3 2's here, and there's 3 2's here, right?
Mm-hmm.
And how can we simplify this?
I don't know.
So remember from before, let's say I had 2 cubed times 2 cubed, right? How can I expand it? So you were correct at the beginning. You can expand 2 cubed as 2 times 2 times 2, right? Right?
Yeah.
Yeah. And you do the same thing for the second one. So in the end, how many 2's do you get? You have 3 on the left and 3 on the right. And in total, how many 2's are there?
6.
6. So you can simplify this as 2 to the 6th power, right? It might not be very clear now because it looks like it's just 3 plus 3. But let's say I change this 2 cubed squared. I change it to 2 cubed cubed. Okay, I'm gonna clear out a bit of stuff. How would I simplify it? You're on the right track, Sean. Just keep going.
Okay.
So so I cube when I cube something, I multiply something 3 times in a row, right? Is that correct, Sean?
Wait, is it 2 times 2 times 2
Hmm.
times 2 times 2?
Okay, so I have 2 times 2 times 2. That's in the first box or first bracket. And then I do 2 times 2 times 2. It's in the second box. And then what about in the third one?
Times 2 again?
Yeah, I do 3 more 2 times 2 times 2's. So in total, how many 2's are there?
9.
9. Wow, that's lots of 2's. You get 2 to the 9th power. So what's a relationship? You see a 3 and a 3. Is it 3 plus 3? Is 3 plus 3 equal to 9?
Yeah. No.
Oh, no. So what, how do I get 3 and 3 to be 9? You see the relationship?
You multiply it by 2.
Well, yes, you would square them. You just do 3 times 3, right? So you
Mm-hmm.
take 3, you multiply it by 3, and you get 9. So in this case, 2 cubed, and then you cube it again, you get 9. So you can simplify this really quickly. Instead of writing everything I just did, you can just write it as 2 cubed, and then you cube it again, is equal to 2 to the 9th power. And you can actually continue doing this. It doesn't need to be 2 cubed cubed. Let's say if I wrote 2 cubed to the 100th power, how would you simplify it? So instead of 2 cubed cubed, I put 2 cubed to the 100th power. So how would you simplify that, Sean? It's not 3 plus 100. You get 2 to the power of something. Ryan,
You mean how to simplify this?
how would I simplify it so that's just one exponent?
So first, you just do 2 times. So you just do 3 times 100.
3 times 100, exactly. So 3 times 100, what is that?
300.
And 300.
2 to the 300th power. Wow. So you can, I mean, it doesn't help much. You still have a really big number, but you can simplify this really quickly as 2 cubed, and then you take it to the 100th power to get 2 to the 300th power. This would be would be the answer over here. So if you have a number and you raise it to an exponent, then you just do multiplication. Okay? So it's kind of they kind of reduce the operation. So instead of doing multiplying, for example, if I had 2 cubed times 2 cubed, you don't multiply. This is just 2 to the 6th, right? Because 3 plus 3 is 6. But if I have 2 cubed and then I raise it to the cubed power, then I get 2 to the 9 because 3 times 3 is 9. Now I know this may be a bit confusing, but it's a very useful property of exponents that you'll see being used a lot when you enter high school. I think we can move on to the next page. This was actually I went off on a bit of a tangent, but last time I think we were talking about prime factorization, and I'm pretty sure we came across something that went like this: 64. Do I have a volunteer? Garrus, can you help me factor 64, please?
Let me think.
So 64, what goes into 64? We're using factor trees here. Can you tell me a number that divides 64? A prime number.
Let me think.
So starting with 1.
8.
8. Okay, fine. Let's go with 8. So 8 goes into 64. So what's 64 divided by 8? Yours?
What?
So what's 64 divided by 8?
64 divided by 8.
Yes, Garrus? Did you say something?
Nothing.
So 60, you know what multiplies by 8 to get 64? It's the so if I asked you what is 8 times 1? So Garrus, what's 8 times 1?
1 is 8. 2
Yeah,
times
8
8
times
is 12.
8 times 2. Okay, 8 times 2 is what again?
8 times 2 is 16.
8 times 3.
So 4.
24. 8 times 4. So you can just keep on adding 8s.
And then just keep on adding 8s
Right,
until
so until you get to 64. So what multiplied by 8 equals 64?
I think it's 8 times 8.
Exactly. So 8 times 8 is equal to 64. Now, we're not done yet because what do you know is what numbers divide into 8? Can you think of a number that goes into 8? That's not 4. Okay, let's say 4. So what's 8 divided by 4?
8 divided by 4 is 2.
Is 2. Okay, so does anything go into 2?
1.
Okay, well, of course, 1 goes into 2, 2 also goes into 2, but no other numbers go into 2, right?
Yep.
So 2 is a prime number. If you remember from last class, we learned that prime numbers are only divisible by 1 and itself. So in this case, we can't simplify 2 anymore. What about 4? Can we break down 4 into any other numbers?
Yep. 2.
Yes, 2 and
1.
okay, well, what's 4 divided by 2? We're just breaking it down piece by piece.
4 divided by 2 is 2.
4 divided by 2 is 2. Boy, do we have a lot of 2's here. We have 1 2, we have 2 2's, we have 3 2's. Oh, look, we still have an 8. Well, what do we do with this 8? Yours?
I believe. Oh my god, I forgot. Oh yeah, the same thing.
Exactly.
Basically.
So
And then a 4, and then a 2, and then a 2, and then a 2.
4, and then a 2, and then a 2. So it's the same thing. Now, if we see here, we have 1 2, we have 2 2's, we have 3 2's, we have 4 2's, we have 5 2's, and we have
And then a
6.
6.
Exactly.
We have
So
a lot of
6.
2's.
We do indeed have a lot of 2's. So we see that 64, if I just write it out here, it's equal to 2 times 2. And if you recall from last class, I spent
Times
this
2
minute
times 2
writing 62 in a
times
row.
2.
Exactly. And this is very tedious, and honestly, my hand is already hurting from writing all these 2's.
I
How would I write this?
know we're writing so many 2s.
We are writing so many 2's. How would I simplify this really easily? You ready to learn, Garrus?
Really easily.
Well, we can express it as an exponent. You remember from up above,
Oh, yeah.
we learned how to write this giant multiplication sequence as an exponent. And how would we write it?
1, 2, 3, 4, 5, 6. So
6 2's, right?
write the 2 and then make a 6 beside it.
Right. We write the 6 at the top right. It's the power. If it's like the 6 makes the 2 really, really powerful. That's how it gets so big and fat and massive all the way to 64. So we see that 64 is, if you just break it down into all its components, you get 2 to the power of 6. We see that it's much easier to write this little thing than writing this giant mumbo jumbo that'll break your hand eventually.
I
So
mean, it might break your hand.
it might, but
It might or may
it's
not
much
break your
easier.
hand.
It's much easier to write 2 to the power of 6.
Yeah.
Right, Garrus? So this is one reason why exponents are very useful. You don't have to write 2 times 2 times 2 times 2 times 2. Yes, Jason? So you don't like to write 2 times 2 times 2 and then spend your entire life doing useless work. You just finish it off with an exponent and say, adios, I'm done. That's that's the joy of using exponents. So I think right now I'd like to teach you guys one more thing before we start on with the Kahoot. Remember, today we reviewed the 2 multiplication rules. One of them was the division by 2. The other one was division by 3. I think we also missed division by 9, but I'm actually going to start with something else. Let's say I give you this number. I'm going to type in another big random number in. Oh, whoops. I send it to a personal person. I'm just going to type in another random number. Can you guys tell me if this number is divisible by 4? And right now you might be like, even, why are you asking me this? You didn't teach us how to divide by 4. You only taught us how to divide by 2, right? So what can I do? Well, let's give it a try. Is this number divisible by 2? Ryan says, okay. So first of all, is it divisible by 2? Ryan says no. Why isn't it divisible by 2? Or are you saying no to divisible by 2 or divisible by 4?
4.
4. Why isn't it divisible by 4? I can actually spot right away that it is divisible by 4.
Because like if you add them up, it's just 43.
Well, I'm asking for divisible by 4, but not divisible by 3. So remember, you don't want to say, I'm going to use a hammer to open this door. Like that doesn't work sometimes, right? You want to use your hand, turn the wrench, and then open the door. You don't use hammers to open doors most of the time, especially if it's like a steel door. It's like when we're talking about math, you don't use the wrong tools for the wrong things, right? I taught you how to find if something is divisible by 3, and
It's
presumably
6:45.
you can tell me that this number is not divisible by 3, right, Ryan? Because you added it up, it's 43, it's not divisible by 3. But
Yeah, but what's the correct way?
what's the correct way? Ah, that is interesting that you ask. Well, how would you find if this number is divisible by 4? Well, first, can you guys all tell me is this number divisible by 2?
You mean
We're starting simple first, okay? Can you guys tell me if this number is divisible by 2 or not?
You mean the number you just said? Yeah.
Yes, it is divisible by 2. And I'm pretty sure you guys can all tell me that because it has 6 at the end, it is divisible by 2. But let's look at the 56. Look at the 56 at the end, right? we know that 56 is divisible by 2. Is 56 divisible by 4? Yes, Garrus?
Wait, I accidentally did that.
Okay, well, I'm gonna pick on you anyways, and I'm just gonna ask you if 56 is it divisible by 4?
I think so.
You think so? Well, we can actually work it out right now. I know this is I'm doing the long way to show you why this process works, but if I gave you another number, you guys can probably work it out almost as fast as I can. So if we just use long division, let's see if 56 is divisible by 4. What do I put up here? Ryan, you can speed through this if you want. Just turn on your mic, tell me the answers.
1.
1, I put a 1 on top. Someone else, what would I put down here? So 1 times 4 is 4. So over here, I would put, Aaron, can you tell me what I put down here? Like in this dash I just put? I threw a
4.
4. Yes, thank you, Aaron. And then what would I get left? I think Shivan says 1. So I drop a 1 and then I drop a 6. So 16 divisible by 4? Aaron? Yes, thank you, Ryan. So 16 is divisible by 4. So in the end, we see that 56 is divisible by 4, right? And now that giant number we just had, let's go back up. The number, I think, was 878956. So if you know your addition, we know that 878956. Do you guys want to guess how we can break this down? We just found out that 56 is divisible by 4. How would we break this number down?
Divided by 56.
Divided by 56. That's hard, man. 56, you got to do the long division, and you might as well just divide by 4 in the first place. So, and in terms of breaking it down, you can actually break this into an addition question, right? So you can write this as 878900, okay, plus 56, right? You can write it this way. You guys see that? Because, if you just do the addition, the 56 just fills up the zeros, and then you get the exact same number, right? Yes? So, we found that 56 is divisible by 4. And how would I tell right away that 878900 is divisible by 4? You guys want to guess? So 878900, it's a factor of 100, right? So 87, if I write this out, 878900 is the same thing as 8789 times 100. And we know that 100, can someone tell me, is 100 divisible by 4?
Yes.
Yes. So what's 100 divided by 4?
25.
25. So we can write this thing. So 8789 times 100 is the same thing as this. I'm not even going to write it down. This number actually doesn't even matter. So some big mumbo jumbo times 4 times 25, right? And 4, it's the same thing as 2 times 2. So we can write it as 2 squared. And 25, it's the same thing as 5 squared. Now, the reason this works is because this 100 is the same thing as 10 squared, right? Because 10 times 10 is 100. I think it's getting a bit confusing right now, but the main thing to consider is that if I give you a really big number, okay, some mumbo jumbo here, and then I gave you, for example, 72. You only need to look at the last 2 digits, okay, and see if that number is divisible by 4. Because remember, for 2, if we wanted to test if a big number is divisible by 2, we have some big number jumbo, and then we have a number over here. We saw that this number, if this number over here is divisible by 2, then it's even. If these 2 numbers are divisible by 4, then this is divisible by 4. We can actually keep on going. If I have some big mumbo jumbo, if I have, for example, 800, and these three numbers, they're divisible by 8, then it works as well. And we can actually keep pushing on. You can go 2, 4, 8, 16, 64, and just can continue going on like that. And you can just keep on telling if some number is divisible by 4 or not. I think the bottom process does get a bit complicated, but it's actually the same logic for why a number is divisible by 2, and so on. Okay, so I'm gonna give you guys another question. Is 464 divisible by 4?
Yes,
Yes. Why is it divisible by 4?
because the last two digit is
Divisible by 4.
by
Mhm.
4, yeah.
Exactly. So same thing. If I go, I'm actually gonna go mad on this. Okay, is this giant mumbo jumbo divisible by 4?
Yes,
Yes. Why is it divisible by 4?
the last digit is divisible. It's a 4.
Right, the last you have to look at the last two digits, remember? It's not just the last digit, because if I told you like 14, is this divisible by 4? I mean,
Nope.
you said no. Well, it is no, because just from experience, 14, it's just not divisible by 4. But that's why you have to look at the last two digits. You don't just look at, for example, oh, there's a 4 at the end. It's divisible by 4. No, that's not how it works. You have to look at the
Well,
last two digits.
since
Yes.
since it's divisible 4, it's still 4.
Uh, so if it's 0, 4, yes, it is divisible by 4 because the last two digits, they're divisible by 4, right? Or if it's 0, 0, that's also divisible by 4. Because, for example, 100 is divisible by 4, right? I think I went a bit too deep today. But I hope most of you guys understand how we can use like exponents, well, to continue finding divisibility rules, basically. So would you guys like to start the Kahoot and clear the screen?
Okay.
Okay, let's start the Kahoot then. Hopefully everyone's logged in. I think we only have like 5 people, 4 people. So if you guys can all get logged in right away, we can get started.
Could you wait for a minute or two? I just gonna get in again.
Okay, all right. I'll post the link in the chat. Early today. Thank you, Jocelyn. And Ryan, are you in yet?
Almost.
Almost? Okay. Aaron's in. Awesome. And Ryan, let's go. William, perfect. Okay, well, I will be starting, ladies and gentlemen. Here we go. Okay, sorry. Okay, I think everyone's answered by now. I'll skip it. Actually, I just remembered. I forgot to teach something. Is that if I gave you 2 to the 0th power, this is actually, it happens a lot. 2 to the 0th power is equal to 1. And the reason this happens, it requires some pretty complicated math. But you can actually kind of guess the pattern. Let's say I wrote 2 to the 4th, okay? 2 to the 3rd, 2 squared, 2 to the 1st, and 2 to the 0th, okay? And we see, what is 2 to the 4th? Can someone in the chat tell me what 2 to the 4th is? And actually, I'll just go down the participants list. So Aaron, can you tell me what 2 to the 4th is? Darius, tell me what 2 cubed is. Jason, you can tell me what 2 squared is. Jocelyn, tell me what 2 is. And then Kevin, try and guess what 2 to the 0th power is. All right. You guys can all type in the chat. I just went down the list. So if you guys can do that, that'd be appreciated. Jason says 4. Thank you. Aaron, thank you. It is 2 to the 4th is 16. Kevin, I think you are at 2 to the 0th. You think it's 2. Okay, good guess. We're missing 2 cubed and 2 to the 1st. So Garrus, can you tell me what 2 cubed is? And Jocelyn, are you here? Okay, thank you. So 2 to the 1st is 2. And Garrus, what is 2 cubed?
Wait a second, let me think. 6
2,
or 8?
yes, it is 8 because it's 2 times 2 times 2, right? So we see that from 16 to 8, what do we need to do? From 16 to 8, how do we get from 16 to 8? So it's not addition or subtraction. We see that we got to do something each time. I'm actually gonna, well, so how do we get from 16 to 8? Would anyone like to guess? Can we guys please make this fast? Okay, well, yes, Ryan?
Wait, so what's the pattern?
Yes, just try and spot the pattern.
The pattern is like the digit when the exponents go down by 1, it gets
Right.
divided by 2.
Exactly. So the exponents go down by 1, and these sides always go divide by 2. So from 16 to 8, you divide by 2. From 8 to 4, you divide by 2. 4 to 2, you divide by 2. And Kevin, would you like to re-guess what 2 to the 0th power is? 0. Well, what's 2 divided by 2? Do you see the pattern? So we started from 16, we divided by 2 to get 8, divided by 2 to get 4, divided by 2 to get 2. So what's 2 divided by 2? 1, exactly. So to test that this pattern holds, we're gonna do 3 again. Let's try making this really fast. Same people. Aaron 3 to the 4th, Garrus 3 cubed, Jason 3 squared, Jocelyn 3 to the 1st, and Kevin, I'm giving you the hard job of once again guessing what 3 to the 0th is. Okay, Aaron, go ahead. 3 to the 4th is? Okay, thank you, Jocelyn. I see you're pretty fast, even though it's a pretty easy question. 3 to the 1st is 3. Okay, Aaron got it right, 81. Garrus, what is 3 cubed? So it's 3 times 3 times 3.
Oh wait, I was looking at the wrong question.
Ah. So what's 3 cubed?
I believe that's 9 or something.
3 squared is 9,
Oh wait,
because 3 times 3 is 9. What's 9 times 3?
12.
9 times 3, not 9 plus 3.
Oh wait.
Remember, these are all multiplication. We're doing lots of multiplication today. So 9 times
Right.
3 is 20.
23.
Close. So 9 times 3. So how would you do 9 times 3? You can add the 9s, right? So what's 9 plus
It's
9?
7 o'clock.
9 plus 9 is
27.
27. Okay, so 3 cubed is 27. Let's go down this real quick. What's 81? From 81 to 27, what do we need to do? Ryan, can you fill us in?
Divided by, the pattern is you keep dividing it by 3.
Exactly, you keep dividing by 3. 27 to 9. Divide by 3. 9 to 3. Divide by 3. And 3 to something, divide by 3. And I think Kevin guessed correctly. It is 3 to the 0 is equal to 1. So anything to the 0, even if it's like some really, really big number, if you raise it to the 0th power, it's equal to 1. All right, just real quick tip. I forgot to teach it today. But that's that. Let's move on. What's 2 to the 5th equal? Okay, 8 answers. Let's go. Yes, everyone did get this one correct. I will move on. Remember, it's multiplication. And not just 2 times 5, it's 2 to the 5th power. So it's 2 5 times. Multiplied by itself 5 times. All right, moving on. Okay, this one is 5. We're asking for the base, not the actual value. You'll see that come up later. So don't rush. Okay, let's move on. It is once again 2. Remember, I'm not asking for the value. I'm asking for the exponent, not the value. The exponent is the number at the top. All right. Okay, now I'm asking what is it equal to? Okay, moving on. Aha, it's 25, not 5 times 2, it's 5 times 5. This was actually pretty much the entire lesson today. We're learning exponents, which in this case we just break it down to 5 times 5. Okay. Okay, we actually did this too. I think Aaron did this one. It's also in the chat right now if you want to cheat. But okay, let's move on. It is 81 and not 12. Remember, it's not 3 times 4. It's 3 times 3 times 3 times 3. Don't simplify and go like 3 times 4 7 or 3 times 4 12. It's 3 times 3 times 3 times 3. Okay? Don't mix it up with multiplication. This is lots of multiplication, not just one multiplication. Okay, moving on. Oh, we did this one too. Using exponents and not just the big factor form. I think class is going to end soon, so if the 8th person, thank you, could speed up, let's go along. Aha, so I did mention using exponents, so in this case, the correct answer would be 2 to the 6th power. We don't write 2 times 2 times 2 times 2 because it's very tedious and, you know, mathematicians don't use it a lot. Oh, got a big score change. It's a prime factorization. You don't just write 36 to the first, okay? So I think this is a bit misleading. Let's move on. Oh, nobody got this one right. Okay, I'm gonna have to cover this again next class. Because I don't think I covered prime factorization enough, but we'll see. And for those answering red, it's not red. Okay, moving on. Okay, nice. Last question. Okay, I talked about this just 5 minutes ago. And okay, well, if you didn't notice, there was a 0 on top. So whatever giant gibberish is raised to the 0th power, it's always going to be equal to 1. Kevin also put it in the chat, so well, it probably wasn't obvious, but I did mention that whatever raised to the 0th power is equal to 1. Okay? Drumroll, please. You guys can all turn on your mics. Is it? Kevin? Okay, good job. Ryan, top G, okay. And we have, okay, well, lots of G's here. I mean, we probably have as many G's as exponents today, but a round of applause for G, whoever that person is. And I'll see you guys all next week. Adios. Have a great day.
Bye.
See ya.